Okay, so 6-7 says graphing and solving quadratic inequalities. So we're going to do both things. We're going to graph them and we're going to solve them quickly. So remember some things that when we graph inequalities. First of all, solid or dashed. Remember those ones? So remember it's dash if it's a greater than or a less than. And it's solid if it has the equal to with it. Remember that part? And then it says, so you're going to graph it, decide if it's solid or dashed, test a point inside the parabola. If the inequality is true, shade inside the parabola. If the inequality is false, shade outside. Okay, well, we sort of had a trick when we were doing it with lines. When we were doing it with lines, as long as it was in y equals form, if it was a greater than or equal to, we shaded above. If it was a less than or equal to, we shade below. So that still works here. We can still do the above and below. Think about it as like above your parabolas or below your parabolas. It'll be inside or outside. Okay, so look at number 1 there. It says y is greater than x squared minus 2x minus 2. First of all, let's think about this guy. Is he going to be solid or dashed when we graph him? He'll be dashed because he doesn't have the equal to with him. Okay, I'm going to throw this guy in my calculator. All right, here we go. So there's my calculator. I've got x squared minus 2x minus 2 and then I'm going to go ahead and change this guy so I can see him in my calculator. So remember, if you arrow over to the left, sometimes this box pops up, and sometimes if you arrow all the way over and you push enter, then you can change it there. I don't have my new one with me. It's at school. Oops. Green on that button. All right, so let's graph him to see what he looks like, and then we'll put him on our paper. Oh, hold on 1 second. Now I'm going to graph him. There he is. Okay, remember your calculator has a, let's see if I can get that any better. That's a little bit better. Your calculator has the table features. So I'm going to do second graph so I can look at my table and then graph the ones that are easy to. -1 and +1. 0, I'm at -2. 1, I'm at -3. 2, I'm at -2. 3, I'm at +1. And then he's going to be dashed. Remember, he's not a V shape, he's a U shape. All right, now our calculator told us to shade inside, but let's think about that. This guy over here said if he was a greater than, then I'm going to shade above. So if you think about them just like this, shading above would be over here. And shading above this line would be over here. So I'm going to shade inside my parabola. It also said you could test a point, just like we were doing before. You can also test a point. So the easiest point to try is 0, 0, as long as your graph doesn't go through him. So is 0 greater than 0 squared minus 2 times 0 minus 2? Okay, so is 0 greater than, that's 0 minus 0 minus 2. Is 0 greater than negative 2? Yes. So I want to include 0, 0. Okay, questions on that? So, on your homework, the first 3 on your homework, you're just going to put them in your calculator and graph them. Does that make sense? Perfect. All right, now these guys say to solve it algebraically. So 2 through 5 say to solve it algebraically. All right, think back to the very beginning of the chapter when we were solving them by graphing. What were we looking for when we were solving them by graphing? Let me see if I can find it. These ones. How do we get these points? What's going on right here? We said these are our 2 solutions, and what is my graph doing at those 2 points? It's crossing the x-axis. Go ahead, JT. Perfect. It's crossing over the x-axis. So I'm looking here to say, okay, at these 2 points, my graph is above the x-axis, and after these 2 points, it's below. So I could say at this point, these 2 points right here, my graph is greater than 0, and over here, my graph is less than 0. So these 2 points right here are pretty much indicators of where it crosses the x-axis. That tells me if it's greater than 0 or less than 0. Okay, so let's look at the first one here. It says solve x squared plus x is less than 2. Okay, everything that we've done so far, we want that guy to be 0. So let's go ahead and move the 2 to the other side. So we have x squared plus x minus 2 is less than or equal to 0. Okay, remember that if this guy factors, he'll cross at nice pretty numbers. So let's see if this guy factors. In fact, most of these will. All right, I need 2 numbers that multiply to 2. A plus and a minus is a plus and a minus, so they're going to subtract to give me 1. Okay, so what 2 numbers multiply to 2 and subtract to give me 1? Perfect. Thanks, Abigail. Okay. Now, if this guy were equal to 0, right, we would set those guys equal to 0. So x plus 2 is equal to 0. and x minus 1 is equal to 0. So x equals a negative 2, or x is equal to positive 1. Okay, but this guy didn't have an equal sign with him. He had an inequality with him. So let's see what's going on. I'm going to draw a number line. Now, if you notice, even on that one I just showed you, we talked about this guy right here. Here I said my graph is above my x-axis between the points of negative 4 and 0. Think about that guy as an and, right? Remember those guys when we were solving them? We were getting an and, right? Then I said it's less than 0 if it's over here or over here. So that guy's an or. Does that make sense? I'm too zoomed out. He's got an or. Remember, ands do this. They give you an interval. Ors go out. All right, so if we look at this guy, I put my two numbers that I got from factoring. If I were to sketch this guy in, he would be a parabola that crosses at those 2 points. Okay? And he opens up because the x squared is positive. In fact, let me just sketch it in for you. He would be a parabola that does something like this. He's solid though. Okay? I want to know when this guy is less than 0. Well, that would have to be between these 2 points because he's below it. So let's check it to make sure. What is a number between negative 2 and positive 1? Easiest number to 0, right? So let's try 0 into this guy up here. All right, so 0 squared plus 0 minus 2 is less than or equal to 0. Is negative 2 less than or equal to 0? Yes. That means this guy is an and I need to write my solution as an and. Smaller number first, bigger number on the other side, variable in the middle, crocodiles eat what's right.
I'm confused. How? Can't they go upside down too? Like,
the x squared is positive, so this guy is going to be facing up. Yeah, so see this guy right here? My x squared is negative, so he would be going down. Yeah. Yeah. You're welcome. Okay, other questions? Okay, so you're going to factor it, find your 2 points. You don't have to sketch it in necessarily if you don't want to. Try a point in the middle. If it's true, it's an and. If it's not true, then it will be an or. Okay? All right, so let's try 3. Now, these guys aren't exactly very nice to solve with a negative x squared, right? So let's go ahead and divide everybody by a negative 1 to make him easier to factor. So I'm going to factor x squared plus 6x minus 7. Okay, I have a plus and a minus. So it's going to be a plus and a minus. I need two numbers that multiply to 7, but subtract to give you 6. Thanks. Awesome. Thanks, Sasha. That means x equals -7 and x equals +1. Right, so there's -7, there's +1. Okay, do you want me to sketch in the parabola? So you can see him? He would be negative, so he's going to open down. So I have a parabola that goes like this. And I want to know when this parabola is less than 0, so below my line. Is this guy going to be an and or an or? It's going to be an or because he's below my line, below my x-axis, between smaller than -7 and bigger than +1. But let's try 0 just to make sure. So if I try 0, because 0 is between -7 and 1, is -0 squared minus 6 times 0 plus 7 less than or equal. That's hard to see. I'm very sorry. Is 7 less than or equal to 0? No. So I don't want to be in the middle. I want x's that are smaller than or equal to -7, or x's that are bigger than or equal to 1. Yeah, so like he'd be this way and that way. Think about this here is my x-axis. It doesn't matter where my y-axis is, right? So there's my y-axis. There's like my y-axis there. So I want to know when he's below the x-axis, and this guy also wanted to know when he was below the x-axis. So see how they were both less thans? If it were a greater than, then I would want to know when he was above the x-axis. Should we try some on your homework? Yeah, would that help, JJ? Okay. So let's go look at your worksheet. I'll come back and do these two with you here in just a second, but they're a little bit, these are special case ones here, so I want you to get practice with ones that are okay, that are normal-ish, I should say. Okay, so look at your worksheet here. These first three, you're just going to put them in your calculator in shade. Solid, solid, dashed. Make sure you do that. Okay? Let's do 4, 5, and 6 together really quick. So, number 4 here says, use the graph of its related functions to write the solutions of each inequality. This one says, when is my graph less than or equal to 0? When is my graph equal to my x-axis or below it? This one's kind of a special case too. 1, 2, he just touches it right there at 3. So this guy is x equals 3. So he's a special case as well. Okay, so now let's look at 5. When is my graph, this is now a greater than or equal to 0. So when is my graph above my x-axis? Let's see, these are go by 2s. 2, 4, 6, that looks like negative 8. And there's 2 and then positive 4. Is it above my x-axis in between these two or outside of those two? He's above. He's above my x-axis. My graph is above my x-axis from negative 8 to positive 4. This guy's greater than, so I want above. So my graph is above my x-axis between negative 8 and positive 4. Right, so it starts right here. So starting at negative 8, it's equal to my x-axis. Then it's above it this whole time, all the way over here to 4. And it's equal to it at 4. No, this one's not shading anymore. So these ones right here, the top ones, those ones you're just going to throw in your calculator and just graph and shade. So see how this guy is y equals? And then these guys are equal to 0. So when it's equal to 0, we're more looking for a solution. So these three at the top, your answer is your picture. These three we're trying to figure out when they're greater than or equal to 0. Or this guy's going to be just greater than 0. So number 6, I want to know he's a greater than, so I want above. When is my graph above the x-axis? Okay, well he's above over here till this point right here. And he's above here to that point there. And these guys go by 2s? Golly. 2, 4, that would be 5. So x is less than negative 5, or x is greater than 4. Are you okay with those three? Okay, starting down here at the bottom, I like the even ones better, so I'd rather you do the even ones. So here's what you're going to do. The first thing we have to do is we have to factor it. Okay, so look at number 8. We have to factor x squared plus 2x minus 35. So I have an x I have a plus and a minus, so it's going to be a plus and a minus. I need two numbers that multiply to 35, but subtract to give you 2. Perfect. I need a positive 2, so I need a positive 7. Set them equal to 0. Okay, so we factored them and then we solved them. I'm going to say sketch your graph. So my 2 points where he crosses the x-axis are -7 and +5. Okay, so that means that I also have my y-axis somewhere in here. Is this guy going to open up or open down? Is my x squared positive or is he negative? It's positive, so he's going to go up. Perfect. And it doesn't matter what he looks like, we just want him to open up. Okay, now you have 2 choices. You can try a point in the middle. If it's true, it's an and. If it's false, it's an or. Or you can look at your picture that you just made right there. We want this guy to be greater than or equal to 0. So when is my graph above the x-axis? Well, he's above the x-axis over here. So numbers that are smaller than or equal to -7 and numbers that are greater than or equal to 5. So x is less than or equal to -7, or x is greater than or equal to 5. Does that help? Or is it clear as mud? Does that help? Okay. That's good. Thanks, Abigail. Okay, so your 2 choices are pretty much an or an and. Remember, if it's an or, I should see the word or. So it'll be x is less than, it could have the equal to with it, the smallest number, or x is greater than could have the equal to with it, the bigger number. With an and, I shouldn't see the word and, but I should see smaller number, less than or equal to, if it has it with it, x less than or equal to bigger number. Does that look familiar? I'll leave that there for a second. So that's how your answers should look. Like I said, it could have the equal to with it, depends on the problem. If the equal to is with it in the problem, then the equal to needs to be with it in the answer. If it doesn't have the equal, then it shouldn't have it in the answer. Does that make sense? Okay. Usually that's the case. But remember, we had graphs that did 3 things, right? They touched it 2 places, they touched it 1 place, or they didn't touch it at all. So that can still happen. Okay, so the other two ones on your notes are what happens if it doesn't touch it at all. What does that look like? And what happens if it only touches it once? Okay, so let's go back to your notes and let's do 4 and 5. Okay, you can't see it very well because I drew all over it. So 4x squared plus 20x plus 25 is greater than or equal to 0. All right, remember the first thing I want to do is I want to factor this guy. So 4x plus 4 times 25 is 100. I need two numbers that multiply to 100 that add to 20. Awesome, thank you, Shaina. Okay, so we got a double root. That means the vertex is sitting on the x-axis. There's two of the exact same factors. All right, I'm going to trash out a 2, so I get 2x plus 5 and 2x plus 5. So 2x plus 5 equals 0. That means the vertex is sitting on the x-axis at negative 5 halves. Or negative 2.5. My A is positive, so he opens up. So I just sketched him in like that. We want to know, when is my graph above the x-axis? There's 0. Does he ever go below the x-axis? No, so this guy would be all real numbers. So we can get all real numbers. If that guy would have been a less than, and I would have said, okay, when is my graph smaller than my x-axis? When is it below my x-axis? Does that guy ever go below my x-axis? No, so then it would be no solution. Okay? All right, questions on that? If this would have been a less than, then I would want to know when it's below my x-axis. Does my graph ever go below my x-axis? No, so then it would be no solution. So if that was a less than, this guy would be no solution. Okay, perfect. Okay, so let's try 5. Again, I drew all over him. You bet. So see how this guy is a greater than. Think about them same as before. Think about our shadings, right? Above and below. If it's a greater than, I want to know when I'm above my x-axis. So in my picture here, I sketched him in. He's sitting on the x-axis, and my graph is above my x-axis for everything. So this guy is all real numbers. However, if that would have been a less than, then I would want to know when my graph is below my x-axis. Well, he never goes below my x-axis. So if this would have been a less than or a less than or equal to, then it would have been no solution. Is that better, Juliet? You're welcome. It's okay. There's lots going on and it's early. I get it. Okay, let's try 5. We have 16, and again, I've drawn all over it. Okay, we need to get this guy equal to 0. So I'm going to move the 24x. And I also need to rearrange him because that 24x needs to go in the middle. Okay, so this guy's a less than. So I want to know when he's below my x-axis. All right, I have a minus and a plus, so my signs are going to be a minus and a minus. Multiply your first and your last, so 16 times 9. Oops. I need two numbers that multiply to 144. Signs are the same, so they add to 24. Awesome, thank you. Again, we got another double root. So again, the vertex is sitting on my x-axis. Okay, I'm going to trash a 4, so I get 4x minus 3. So 4x equals 3. So x equals 3/4. There's my y-axis. Now, pay attention. This guy does not have the equal to with him. So when is my graph? He's a less than. When is my graph below the x-axis? He has to be completely below. He can't touch it. He needs to be below it. It's never below. So this guy is no solution. Now, if it would have said, when is this guy below or equal to my x-axis, then we could have said it's equal to it at 3/4. However, he doesn't go below my x-axis. So this guy is no solution. Okay, questions on any of that? You bet, yes. If that would have been a greater than, then we would have said, heck yeah, that guy's above the x-axis at all times, so then it'd be all real numbers. Good job, Lexi. You're welcome. Thank you. Okay, anything else? Okay, so what do you need to do for homework? You need to plug those 3 in your calculator, shade them, graph them correctly, and put them on your graphs. Okay, so you've got 3 up there. Then you need to go down to the bottom and do the even. So you have 10 through 20. If you feel like you need more practice, feel free to do the odds as well. I'm not going to make you. So what I want you to do is do 10 through 20. There is only one of them on that side that is either no solution or all real numbers. There's only one. Okay, that's why I like this side better. He's got less special cases. So factor it. Figure out what 2 points you are, sketch in your graph, and decide is he above the x-axis or below the x-axis, and where are those points. Okie dokie? All right. Let me stop the recording.